Are people happy in their marriage? The table below shows the results from 2002 General Social Survey for Marriage. Are married adults classified by gender and level? Suppose one married adult is selected at random. So we're only taking one. I want to find what's the probability that a randomly selected married adult is male and very happy. So, where is a male and very happy? How many of them are those? 221. And we're selecting them just a married adult. So how many are we selecting this out of? 603. So what does that give me? Three, 7. So the probability of selecting a male and very happy is 37%. Questions on that? So what's the probability that a married adult is very happy? 370 of them are very happy out of 603. What does that give me? 0.61. So the probability a married adult is very happy is 61%. At least it's better than half. That's good. There's hope out there. So what's the probability a married adult is male or very happy? So this is my or, probability they're male or very happy. What's the probability that they're male? How many males do we have? 325 out of our 603. What's the probability they're very happy? 370 out of the 603. Is there an overlap that we need to subtract? How many of them? 221 out of 603. Because we double counted those 221 in the males and in the very happy group. So we'll subtract one of them. Let's see what that gives us. Seven, 9. So the probability a married adult is male or very happy is 79%. That's even better. Questions on that so far? All right, we want that conditional probability. So, what's the probability that a married adult is very happy given that they are male? So the difference with this one is that we are knowing that we're in a specific group. We know that we're in the males, and we want them to be very happy. So the total amount that I'm looking at, because I already know they're males, is my males. So my denominator has changed. I'm no longer looking at the entire group. I'm focused in on the males. So how many males do we have? 370. Now, we want to know about the fact that they are male and very happy, right? Because this formula does an and thing here.
Yeah, 325.
Is that how many are males? You're right, 325. All right, then how many of the males are very happy? 221. So the numerator should be the overlap of the event, and the denominator should be the number that we're given, the group that we're given. So the total amount of information we know. Does that make sense? What does that give me? 0.68. So the probability a married adult is very happy given they are male is 68%. Yeah. Assume 13% of students are computer science majors. We'll call that our event A. 15% take discrete mathematics. We're going to call that event B. And 84% of students are not computer science majors and have not taken discrete mathematics. And we want to know what is the probability that the students in the computer science major and has not taken the course in discrete mathematics. So before we answer that question, I want to fill in the table and collect all this information that I've got. Since we're talking about percentages, I know that in total, I should have 100% of information, right? I don't have that exactly right now, but I should. Then, I know that event A is that I have a computer science major, and 13% are computer science major. That's a total amount. So 13% can go down here. 15% have taken discrete mathematics. That's my event B. So overall, whether they're a computer science major or not, they've taken discrete mathematics. That's my total for event B. The last piece of information I have is that 84% of students are not computer science majors and have not taken discrete mathematics. So they are not both of them. Where do you think that goes? What does A bar and B bar mean again? Complement. So they're not a computer science major, not discrete mathematics. Below the A bar, and also in the bar that goes along with having our B bar, the complement. So 84%. With this information, is this enough to actually fill in the table? All right. What can I fill in from this? What's the total amount of percent that are not computer science majors? 80. I'm talking about this box. 87. What's the total amount that have not taken discrete mathematics? 85. Oh, sorry, that's what you thought last time?
Yeah, that's what
Gotcha. Sorry. All right, now I got to try to fill in this higher table, or the middle piece of this table. If I know that 84% have not taken computer science, I can fill in either the ones who have taken discrete and not taken computer science, or not computer science majors, or I can fill in the ones who are computer science majors but have not taken discrete. So if I want to fill in the A bar, the box right below A bar, what percent is that? What about the percent for right next to B bar? And 1%? And what about the last box? So in order to fill in a table, you only need 3 pieces of information. You need 2 outside total pieces and 1 inside piece of information. The rest we can kind of get from there to kind of work it out. So let's go back to our original question, which is what's the probability that a student is a computer science major and has not taken discrete mathematics? So the probability they are a computer science major, that's A, and have not taken discrete mathematics, well, that's my B bar. What percent is that? 1. That's my box right here. That's where they are a computer science major but have not taken discrete mathematics. So the probability would be 1% for that. So I'm figuring out the information that I know, right? And I know they are a computer science major. Well, that's A. That's my event A. But then it said the probability they have not taken discrete mathematics. Well, B bar is where they have not taken discrete mathematics. So you find that overlapping box. I just take the value that's in the box. Yeah. Oh, and I wrote it in the wrong spot, but we'll put our sentence down here. So the probability a student oh, this is a new one. Never mind, sorry. I'll put that up here. Is a computer science major but has not taken discrete is 1%. Now the next one is a new question. So it wants to know what's the probability a student has taken discrete mathematics? Well, that's my B. They've taken discrete. And is not a computer science major. Not a computer science major is my A bar. So where did those two things happen together? 3%. So the probability a student has taken discrete mathematics and is not a computer science major is 3%. What is the probability that someone has taken discrete mathematics is a computer science major? So someone who has taken, that makes it seem like what? Like a given. Like we know that has happened. So we know they've taken discrete mathematics. What's the probability that they are a computer science major? So probability of computer science major is A. And we're given that they've taken their discrete mathematics. Does that make sense? Oh, I didn't write my sentence. Yes, I am. I said it instead.
Okay.
So this one takes a little bit more work though, right? Because I need the probability of A and B divided by the probability of B. We might need the decimals for this, but we can find them. So what's the probability that you are A and B? 12%. What's the probability of B? 15. So in order to actually work with these, let's turn them to decimals. So 0.12 times 0.15. And then what does that give?